Hello friends. Today I am going to tell you about when will time end. If you not subscribed our channel yet, then please subscribe it. Let's start. Time will end in 5 billion years, physicists predict. Our universe has existed for nearly 14 billion years, and as far as most people are concerned, the universe should continue to exist for billions of years more. But according to a new paper, there's one theory for the origins of the universe that predicts time itself will end in just 5 billion years, coincidentally, right around the time our sun is slated to die. The prediction comes from the theory of eternal inflation, which says our universe is part of the multiverse. This vast structure is made up of an infinite number of universes, each of which can spawn an infinite number of daughter universes. Related, new proof unknown structures tug at our universe. The problem with the multiverse is that anything that can happen will happen an infinite number of times, and that makes calculating probabilities, such as the odds that Earth-sized planets are common, seemingly impossible. Normal notions of probability, where you say, event A happens twice and event B happens 4 times, so event B is twice as likely, don't work, because instead of 2 and 4, you have infinity, said Ken Nollum of Tufts University in Massachusetts, who was not involved in the study. And calculating probabilities in a multiverse wouldn't just be a problem for cosmologists. If infinitely many observers throughout the universe win the lottery, on what grounds can one still claim that winning the lottery is unlikely? Theoretical physicist Raphael Basso of the University of California, Berkeley, and colleagues write in the new study. Physicists have been circumventing this problem using a mathematical approach called geometric cutoffs, which involves taking a finite swath of the multiverse and calculating probabilities based on that limited sample. But in the new paper, published online last month at the Cornell University website arXiv.org, Basso's team notes that this technique has an unintended and, until now, overlooked consequence. You cannot use cutoffs as mere mathematical tools that leave no imprint, Basso said. The same cutoff that gave you these nice and possibly correct predictions also predicts the end of time. In other words, if you use a cutoff to compute probabilities in eternal inflation, the cutoff itself and therefore the end of time, becomes an event that can happen. Universe is one bubble in a boiling pot. Despite this odd wrinkle, Basso and colleagues think eternal inflation is a solid concept. Most of the theories underlying scientific assumptions, such as Albert Einstein's theories of relativity, all seem kind of innocuous, and it's hard to see what could replace them, Basso said. See Einstein's gravity confirmed on a cosmic scale. In fact, many physicists think eternal inflation is a natural extension of the theory of inflation, which solved some of the problems with the original Big Bang theory. According to early models of the Big Bang, groups of matter that are now on opposite ends of distant reaches of the universe are too far apart to have ever been in contact with each other. That means the early universe should have been clumpy. What's more, at the rate our universe is now expanding, its overall shape should have curved over time. Also, the initial moment of creation should have filled the universe with heavy, stable particles called magnetic monopoles. But observations in the past few years of radiation left over from the Big Bang say otherwise. The early universe was uniform. The shape of the current universe is flat, and magnetic monopoles have never been conclusively observed. Standard inflation theory accounts for all this by saying the universe experienced a period of extremely rapid expansion in its first few moments, eventually leveling off to create the flat, uniform universe we see today. Eternal inflation is a next step in inflation theory, and it allows scientists to avoid some other tricky cosmology questions, such as what existed before our universe, answer, other universes, and why our universe appears to have properties fine-tuned for life, answer, everything is possible. Also see every black hole contains another universe? Although we don't have a theory, To explain the earliest moments of the universe, we have some pretty good ideas about what such a theory would look like, and these ideas seem to necessarily include other universes, said Charles Lineweaver, an astrophysicist at Australian National University, who was not a member of the study team. A good analogy would be that our theories predict a boiling pot of water, and the origin of our universe is the formation of one of the bubbles at the bottom of the pot. The theory strongly suggests the existence of other bubbles, because when you boil water, you never get just one bubble. Time coming to an abrupt end? But eternal inflation still isn't perfect, as the problem with probabilities in the multiverse illustrates. If probabilities are to work in a multiverse, there must be actual cutoffs that bring various universes to their ends, study leader Boso says. According to the formulas used to calculate cutoffs, a universe that is 13.7 billion years old will reach its cutoff in about 5 billion years, his team concludes. For most people, the idea that a mathematical tool could be elevated to a real-world event might seem strange, but there are precedents for it in physics. For example, Tufts University's alum said, "There was a time when many physicists resisted the idea that protons, subatomic particles with positive charges, are themselves made up of smaller particles called quarks. Related, protons smaller than thought, may rewrite laws of physics. Mathematically, quarks help explain the so-called strong force in the nucleus of an atom, and in the real world they now help account for the zoo of strange particles that's been discovered in accelerators." People said this idea that there are particles inside of a proton that can never get out and that we can't ever see in isolation is crazy, Olam said. There was a long time when people thought quarks were just a useful calculation tool, but they didn't really believe in them. Nowadays, though, everybody believes quarks are real fundamental particles. Along the same vein, if theorists believe in eternal inflation, they either need to believe that cutoffs are not valid techniques for computing probabilities, or that cutoffs are real events that predict the end of time, Boso and colleagues say. What a real-world cutoff would look like and what form the end of time would take are unclear, the team says. If it happens, it would probably be sudden and unexpected. And even if humans could see a cutoff coming, we almost certainly wouldn't be viewing it from Earth. Scientists think our Sun, now a middle-aged star at about 4.57 billion years old, will be reaching the end of its life in about 5 billion years. At that point in time, the Sun will run out of fuel in its core and will start to shed its outer layers of gas, inflating to become a red giant and ultimately a planetary nebula. Earth's exact fate during this event is unclear, but few scientists would argue that life on the planet could survive the Sun's death. End of time not inevitable. Although Australian National University's Lineweaver agrees that calculating probabilities in an eternal multiverse is problematic, he doesn't think predicting a real-world cutoff is the solution. "I never rule out anything completely, but I don't take this very seriously," Lineweaver said. "I'm going to take questioning the assumptions behind eternal inflation more seriously." Tufts University's alum also doesn't think physicists should accept the end of time as inevitable. "Nobody knows why eternal inflation should be wrong, but nobody knows exactly why time should come to an end either. To me, these things are on equal footing," he said. Also see, universe's existence may be explained by new material. Inflation aside, there are many theories in physics for how the cosmos might end. In a big crunch, for example, the universe would reverse its current expansion and shrink into a black hole. Then there's the heat-death theory, in which the universe expands forever until it reaches a state of thermal equilibrium, in which nothing can happen. Yet another idea is called the Big Rip, in which the accelerated expansion of the universe eventually rips all matter apart, atom by atom. Also see Einstein and Beyond in National Geographic magazine. If the theory of eternal inflation is correct, then even when our universe ceases to be, the larger multiverse will continue. No matter which scenario sounds most plausible, there's no need to go off and sell your stocks because the universe is going to end in 5 billion years, Olam said. And either way, we have a long time to get the story right. Thanks for watching. Please subscribe for more interesting videos.